Hi, I'm an old guy and I do maths. The problem today is to find the general solution for this expression here, 2 sine x minus 1 equals 0. For those of you who don't really understand what a general solution is, probably the best way to think about it is to think about, in this case, a sine graph that goes on and on and on in either direction, and we're looking for all the points on it that conform to this once we have this slightly rearranged. And obviously we need an algorithm for that. And the algorithm comes in the form of a starting point and then something that we add or subtract to that starting point. So this will become a little clearer as I work through this. Now, the first thing I need to do is to rearrange this slightly. So sine of x equals 1. So, sorry, 2 sine of x equals 1. Therefore, sine of x is equal to 1/2. Now, having got our expression into this form, we go looking for where the sine of x is equal to 1/2. And that requires us to resort to our little trig triangles. Now, this is half of an equilateral triangle, 1, 2, root 3. Again, if you're slightly unfamiliar with this, it probably pays to have a look back at some of the earlier videos in the trigonometry playlist, the circular trigonometry playlist. But this angle here will have a sine of 1/2, 1/2. And because this was half of an equilateral triangle, and this is 90 degrees, this will be 60, and this will be 30, which is pi on 6. So that's a starting point for us. Okay, now if we look at the unit circle, badly drawn here, pi on 6 is somewhere here. And sines are positive here. We're looking for a positive value. Sines are also positive over here. And this angle here is going to be pi on 6. So that's pi on 6 off the x-axis. It is going to be from here 5 pi on 6. So these are our two starting points, pi on 6 and 5 pi on 6. Now, if we add 2 pi to pi on 6, we get back round to here. When I was talking earlier about the endless nature of a sine graph, or for that matter a cosine graph, or for that matter a tangent graph, if you ignore the asymptotes. What we have with a sine graph is we have this sort of continual wave, and pi on 6 is here, 5 pi on 6 is here, but we also find that we've got values here and here, and so forth and so on, and indeed back in this direction as well. So what we can say is that we could add 2 pi to this and get back to here. We could subtract 2 pi from it and get back to here. So one of our general solutions will be as follows. It'll be pi on 6 plus or minus 2 pi times n, and n is simply the number of times that we go around in either direction. To get back to where we started. The other solution will be 5 pi on 6, and you guessed it, plus or minus 2 pi n. And those are our general solutions. They can be written in different ways, but for this video I've chosen to write them this way because it's nice and clear what's going on. The n simply represents the number of times that you go around the unit circle in either direction. If we take this point here, which is 5 pi on 6, this point here is 2 pi beyond that. So 2 pi times 1 beyond that, and so forth and so on. Okay, now I hope that was clear. The process is as follows. Get your expression into this form, find its value in terms of radians, find its position on the unit circle, and work out from there what it's going to take to get back to this point, or in this case this point. Now sometimes, and this is just a bit of an addition, sometimes you have an expression that gives you a point here and maybe a point opposite on the unit circle. In that case, we're probably just adding or subtracting pi. But in this case, we're adding or subtracting 2 pi and its multiples. So it could be 2 pi, 4 pi, 6 pi, whatever. Okay, thanks very much for watching. I hope you found this useful. If you did, please like and subscribe, and I will see you next time. Bye.